Namaste, my friend, and welcome to JEE Chemistry with Typical Monk. This is class 10, and today we talk about equilibrium. Picture a flask sitting perfectly still, as though the reaction has stopped. But inside, the forward and the backward reaction never rest. Both run at exactly the same speed. When Sarah first heard this, she asked, if both reactions are still running, then why does nothing seem to change? That stillness is the whole magic of equilibrium. And in G, that same stillness opens up into Kc, Kp, Le Chatelier's shifts, and a full ice table numerical worth, real marks. Today, one idea at a time, we build this balance from the ground up. Take a slow breath. Let us begin. So what will you carry home from today's class? First, reversible reactions and dynamic equilibrium. Nothing here ever fully stops. Second, the law of mass action, Kc Kp, and the relation that says Kp equals Kc into RTC into RT raised to the power delta N. Third, the reaction quotient Q. Comparing Q against K tells you which direction the reaction will move. Fourth, Le Chatelier's principle, how a stress shifts the balance. And fifth, the G drills, an ice table Kc numerical, degree of dissociation, and a fully numerical quick check. Ready? One idea at a time. Let us begin with the most basic identity of equilibrium itself. First, reversible. Products can turn back into reactants. The reaction runs in both directions at once. David used to think that once a product formed, that was the end of the story, but it can just as easily turn back. Second, dynamic, not dead. The forward rate becomes equal to the backward rate. The motion never stops, it simply balances. Third, concentrations hold steady. The amounts stop changing, not because they are equal to each other, but because the two rates have become equal. And fourth, a closed system. Equilibrium needs a sealed vessel. Nothing may escape, or the balance never forms at all. Look at this graph carefully, because this single picture shows exactly how equilibrium is built. At the start, only reactants exist, so the forward rate is at its highest, and the backward rate is 0. As products build up, the forward rate falls while the backward rate keeps rising. And a moment arrives when the two rates become equal. That moment is equilibrium. Beyond it, concentrations stay flat, but the reaction never truly stops. There is motion inside, even while everything looks calm outside. Lisa used to think a flat line meant the reaction had shut down, but a flat line only means the two rates are now equal. Now let us read the equilibrium constant in its own language. First, the law of mass action says divide products by reactants, each raised to the power of its own coefficient. This is what we call Kc. Second, Kc is built from concentrations, while Kp is built from the partial pressures of the gases. Third, the two are linked by one relation. Kp equals Kc into RT prosed to the power delta N, where delta N is the moles of gaseous products minus the moles of gaseous reactants. And fourth, K depends only on temperature, and pure solids or liquids are dropped out of the expression entirely. Now, the real G twist. A full ice table, solved slowly, the monk's way. Our reaction is phosphorus pentachloride breaking apart into phosphorus trichloride and chlorine gas, and it can just as easily go backward. We are given 1 mole of phosphorus pentachloride in a 1 liter flask, and at equilibrium, its degree of dissociation is 0.5, meaning half of it has broken apart. Step 1. The first row of the ice table, the initial row. At the start, phosphorus pentachloride sits at 1 molar and both products start at 0. Step 2. The change row. Whatever amount breaks apart we call X, and X equals alpha times the initial amount. 0.5 times 1 gives 0.5 mole per liter dissociating. Step 3. The equilibrium row. What remains of phosphorus pentachloride is 1 minus 0.5, which is 0.5 molar, and both new products have also formed to 0.5 molar each. Step 4. Now write the expression. Kc equals the concentration of phosphorus trichloride times the concentration of chlorine. divided by the concentration of phosphorus pentachloride. Step 5. The answer. 0.5 times 0.5 divided by 0.5 equals 0.5. So Kc equals 0.5 mole per liter. And delta N here is +1, so Kp will equal Kc times RT. Now watch which way the balance leans when you apply a stress. First, concentration. Add a reactant and the balance shifts toward the products. Second, pressure. Raise it and the system shifts toward the side with fewer gas moles. Third, temperature. Heating pushes the balance toward the endothermic direction, and this is the one thing that actually changes the value of K. And fourth, a catalyst. It speeds up the forward and backward rates equally, so it never shifts the equilibrium. It only gets you there faster. Now sit up straight. These 5 lines are exactly what JEE keeps asking year after year. 1. Compare Q with K. Q smaller than K means forward, Q larger than K means backward, and Q equal to K means no net change at all. 2. K depends only on temperature, never on concentration, pressure, or a catalyst. 3. Kp equals Kc into RdT raised to the power delta N. The two are equal only when delta N is 0. So watch the sign of delta N carefully. 4. In a nice table, always set X equal to alpha times the initial moles. Never drop alpha alone into the Kc expression. And 5. An inert gas at constant volume causes no shift at all, but at constant pressure, it can shift equilibrium. Now, let us drill the JEE way. Remember the 4 options. Option A, both statements true, and the reason explains the assertion. Option B, both true, but the reason does not explain it. Option C, assertion true, reason false. Option D, assertion false, reason true. First, assertion. A catalyst does not change the equilibrium constant. Reason. A catalyst speeds up the forward and backward reactions equally. Both statements are true, and the reason genuinely explains the assertion. Option A. Second, assertion. At equilibrium, the reaction has stopped. Reason. The concentrations of reactants and products stay constant. Pause and think. The assertion is false, because equilibrium is dynamic and never truly stops. But the reason is true. Assertion false, reason true. Option D. Third, assertion. For the phosphorus pentachloride reaction, increasing the flask's volume increases the degree of dissociation. Reason. Increasing volume shifts the balance toward the side with more moles of gas. Both are true, and the reason fully explains the assertion. Option A. Now, a quick match. Say each answer to yourself before the reveal. Q smaller than K shifts forward. The link between Kp and Kc, Kp equals Kc into RT blessed to the power delta N. Dilution, where delta N is positive, alpha increases. And adding a catalyst, no shift at all. If all 4 answers came to your mind before the reveal, today's class has truly settled in. This is a JEE favorite format. I will read out statements. You silently count how many are correct. Statement 1. A catalyst does not shift the position of equilibrium. Statement 2. The degree of dissociation of phosphorus pentachloride decreases when the vessel's volume is increased. Think carefully about this one. Statement 3. When delta N is 0, Kpo equals Kc. So, how many are correct? 2 statements, the first and the third. The second one is wrong, because increasing volume actually increases the degree of dissociation. It does not decrease it. This is exactly the trap John keeps falling into. Now let me save you a few marks. Myth 1. Kp always equals Kc, and both are unitless. Here is the truth. Kp equals Kc into RT raised to the power delta N. The two are equal only when delta N is 0. And the units also depend on delta N. Myth 2. The degree of dissociation alpha is a fixed constant for a given reaction. Here is the truth. Alpha changes with the initial concentration, the volume, and the temperature. K alone is the one quantity that depends purely on temperature. Now, it is time to test yourself. And today, everything is numbers. The rule is this. I ask, and you answer in your head before the reveal. Question 1. Nitrogen plus 3 hydrogen gives 2 ammonia. What is delta N here? Gas moles of products are 2. Gas moles of reactants are 4. 2 minus 4 equals minus 2. Question 2. If Q is smaller than K, which way does the reaction shift? Forward. Question 3. 2 moles of phosphorus pentachloride are placed in a 2-liter flask with alpha equal to 0.4. How many moles of phosphorus pentachloride remain? X equals 0.4 times 2, which is 0.8 mole dissociated, so what remains is 2 minus 0.8, which is 1.2 mole. Question 4. Hydrogen iodide sits at a concentration of 4, while both hydrogen and iodine sit at a concentration of 1 each. In the equilibrium where hydrogen plus iodine gives 2 hydrogen iodide, what is Kc? 4 squared divided by 1 times 1 equals 16. And question 5. What alone can change the value of K? Only temperature, never concentration, pressure, or a catalyst. Let us gather the whole class into one slow breath. Equilibrium is dynamic. The forward and backward rates are equal, never stopped. The law of mass action gives Kc equals Kc into RT raised to the power delta N, and the two are equal only when delta N is 0. Comparing Q with K tells you the direction. Q smaller than K means forward. Le Chatelier, a stress, shifts the balance in the direction that relieves it, only temperature changes cake itself. The ice table gives the concentrations, where X equals alpha times the initial amount. This is the real JEE numerical engine of this chapter. And next class, we move on to ionic equilibrium, acids, bases, pA, and buffers. Do not miss it. So my friend, today we understood this balance. It might look like nothing more than a flask standing still, but now you know a whole story is running inside it. Forward and backward at exactly the same speed always. Every Kc you will ever compute, every shift you will ever predict, every ice table G will ever throw at you. All of it starts right here. Sarah, David, Lisa, and John, all of them began from exactly where you are standing now. Be patient with yourself. Revise the ice table once tonight, slowly. One idea at a time, you will crack G. I have complete faith in that. If this class brought you clarity, subscribe to the channel so the next class finds you on its own. Until then, keep going. See you in ionic equilibrium.